All right, so this one says one of the brightest stars in the sky is Arcturus. Yeah. Which is a part of the constellation, I don't know how, Boots, whatever, I don't know how to say this stuff. Says it is 32 light years away from Earth. 1 light year is 5.88 times 10 to the 12 miles. Okay? So that is, so this is, so what a light year, you guys know what a light year is?
No.
What's a light year? So a light year, so light particles are called photons. A light year is how fast a photon travels. Okay? So that is the distance. So a 5, an 8, and then 10 zeros. Okay? That's how many miles a light photon travels in 1 year. That make sense? Okay. So the idea is when we're seeing, maybe you've heard people say this, when we're looking at a star, we're actually looking, the light that we are seeing was actually given off by that star perhaps thousands of years ago. Does that kind of make sense? Depending on how far away that star is. So people say when we look at the stars, we're looking into the past. It's because the light that we're seeing is light that emanated from that star many, many years ago. Okay? Yeah. Can you follow along? Yeah. 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 So the 2 8s give me 2 spots, and then 10 more zeros would give me the 12 total. So just here's the question, because the last class had a similar issue, or a couple kids in the class had a similar issue. If I just told you that a year was 365 years, or sorry, a year was 365 days. That's weird. A year was 365 days, and I told you that I'm interested in 32 years. What would you do with the 365? Multiply by 32. Okay. So here we're saying a light year is equivalent to 5.88 times 10 to 12 miles. And if I have 32 light years, what do I do with those numbers? Okay, so I'm going to take, so the idea here is that we've got this 5.88 number. See if we can get this up. All right, so we got 5.88 times 10 to the 12. And we're going to multiply that by 32. Okay? Well, what happens is that number there and that number there are the nice numbers to work with, right? Because I've really got 3 numbers being multiplied together here. I've got 5.88, I've got 32, and I've got 10 raised to the 12th power, which would be that 10 multiplied by itself, 12 times, so that 12 zeros. So, 1,000, million, billion, trillion. Okay? So I'm taking 5.88 times 32 times 1 trillion. Does that make sense? The 5.88 and the 32 actually work best together, so I'll multiply those together. And it gives me 188.16. Okay? Now, I haven't multiplied that number together, right? So the idea is, like, if I had, 2 times 3 times 5, can I rewrite that as 6 times 5? Does that make sense? So that's all I'm doing here. I'm writing 5.88 times 32 is this number, times the 10 to the 12th that is already there. Okay? Now, if I type that in just to prove a point to you, a couple different things here that I want to bring to your attention with this question. If I type in 188.16 and I hit the X for time, or times, they're going to have a problem with that. Okay? You see here it says use the multiplication symbol on the math palette as needed. Okay? The math palette is this thing down here, right? If I look at these, you see that those two, they're a little bit different in their structure. Okay? So we don't want the X because that's referring to the variable X. We want the multiplication symbol, that cross. Okay? But now if I go 10 to the 12th, okay, it's going to tell me I'm wrong. Okay? A check answer says, although your answer is equal to the correct answer, it's not in the correct form. What does that mean? Okay, so that number 188.16 has to be between 1 and 10, right? So where do I need to move my decimal place? To the left. So it's going to go there, right? So now when I moved it 2 to the left, what happens to that? Okay, that exponent, so when you move it left, your exponent increases however many units you moved it to the left. So we moved it 2, and now we check our answer, and then we're good to go. That kind of make sense?
Wait, hold on. Move the decimal point up the exponent of the 4 by 2, right?
Yes. So here I want to explain why, because I'm a person that says, am I going to remember that rule? Probably not. I'm going to mess that up. Because if I go left, I got to move it up, and if I go right, I got to move the exponent down. This is the basis behind that rule. Let's say that I have a number like 23.4 times 10 to the, let's just make it easy, let's go 10 to the 5th power. Okay? If I expand that into what we call standard notation, so no multiplication here, how many places do I move my decimal to the right here? 5. So I'm going to have 2, 3, 4, and then 4 zeros, right? Okay. So that's going to put my decimal right there, correct? Can I now take that number, because that's 23.4 times 10 to the 5th. Can I now take that number and put that back into scientific notation? How many spots do I have to move my decimal? 6 spots to the left to get between the 2 and the 3, right? And that 6 is that exponent. So what happened from here to there? Well, the number out in front, the decimal moved 1 to the left, right? What happened to the exponent on this first one compared to the second one? The exponent went up, right? So that hopefully shows you or demonstrates that when you move it to the left, exponent goes up. When you move it to the right, the exponent will go down. Now, you don't have to associate or attach to moving left and going up or moving right and going down. You can, every time you see one of these that is not in scientific notation, you can expand it, okay, and then put it back into scientific notation. My only concern about that is, we had a power of 12, right? What if they give me like a power of like 38? Do I want to write out 38 zeros and then count back? No. So that there are times where it does make sense to know that rule, or I guess the consequence of moving the decimal and how that impacts your exponent. 14, yes. Lindsay? Sure? Okay. Oh. Okay, so here's what I'm going to do with this one. Because this is going to show up again later on. And we're going to do a little bit something different with it. Snow is frozen. Is that thing right there? Okay, so that, the S plus 6. Huh? Are they used? Some of them are. Just the ones that I've been using. All right, would you agree that S plus 6 and that S plus 6 are the same thing? Yes. Okay, so the same base. So what I'm going to do here real quick is I'm just going to rewrite this as, like, if I had as x to the 8, x to the negative 6. Does that kind of make sense? I'm just replacing the S plus 6 with x. But if I had that, what would you do with the exponent? Add them. So it would give you x squared, right? Okay. Now, so now if I'm looking at the S plus 6 and the S plus 6, now what should go in that box is S plus 6 squared. Okay. Now, I don't know, because I'm going to probably, I don't know if they give you the right, if this counts it. Good. Okay. So what happens, and I wasn't sure, because what happens in the next couple of sections, specifically in Chapter 8, is that we're going to say, okay, well, what is S plus 6 squared? And that turns out to eventually be S squared plus 12S plus 36. And we'll talk about that. If you can multiply, you guys can distribute, right? That's all that's going to go to. So eventually we'll take that and do something else with it.
What's the next one though?
15?
The next one too, yeah. That one's if you look at
Okay, so what numbers work the best here?
No.
Okay, the basis. Okay, so the basis. So I'm gonna rewrite this real quick. I'm gonna restructure it as 7 times 2 times 2 times 7, right? Let's look into all these coefficients, right? And then I got the b values. So b to the 5 halves, b to the 7/8, right? K to the 7/8, and k to the 5 halves. Okay. So if I do that, 7 times 2 times 2 times 7, is that 748? Huh? Ah, yeah, okay. Is that 196?
Yeah.
What was I thinking?
What were you thinking?
I don't know. Oh, last class, I think these were 4s. I'm sorry. So I was trying to remember from, let me see if I got it on my calculator still. Yeah, last class those were 4s, and that would have been the 784. All right, so 196. So 196. Now, if I've got these two bases of b, what do I do with their exponents? Add them. Okay. So it's the exact same process as before, right? But what are those exponents? Fractions. So I'm going to add fractions. What do you have to have? Common denominator. So what is that common denominator here going to be? 8. Okay, so if I make that bottom one 8 there, obviously the 7/8 stays 7/8. What is that numerator going to have to become to do that? What do I multiply that by to get 8? Okay, so I multiply that by 4 to get 8, so I got to multiply the 5 by 4 to get 20. So now I get 27/8, right? Does that reduce? No. Okay, so it's just going to stay b raised to 27/8. And now when I work with k, is k going to be the same fractions that I'm adding together? Yeah, so k is still 7/8 plus 5 halves. So that's going to be 27/8. So 196b to the 27/8 times k to the 27/8. So this question, all this question is getting at is it does not matter what kind of numbers you have as exponents. You're going to add them, right? And then what if they're fractions? When you add fractions, you got to know what those rules are. Okay. If they were radicals, we would have to know how to add radicals, and that's something we'll talk about in the future. Haven't hit that yet. But your exponents, no matter what they are, all you do is add them. Okay. Now that might incorporate a particular set of procedures that you use or set of rules that you use to add those types of numbers together. In this case, common denominator. Yes.
Because they're back in lunch now.
It'll be there in a little bit.
No, Mr. Say already did all this stuff.
But we're going to go on to new notes here in a moment. I don't want you to miss anything. Hurry, go.
Practically. Not practically enough.
So not.
I did it backwards. It's like, wait. So if I do that, like the 5, look, I did that.
Okay, so that's fine. So then, so you go 5 halves plus 7/8, right?
Yeah, which is basically what you just did, which would be 28. Oh, wait, how'd you, yeah, 27/8. And then just, I don't know why. No, you know, I don't know what's wrong. You know, you can take this. Get a shot, like right here. You can taste the iron and back it up.
So B 5/8, 5 halves plus 7/8. That's what we had, right? 5 halves plus 7/8. 27/8. Let me see if I can pull yours up real quick. It stinks when you can't read.
I'm mad about that.
We'll get yours individually. So here it says a liter of water contains about 3.35 times 10 to the 25th molecules. So a certain river discharge is about 2.9 times 10 to the 8th liters of water every second, right?
Oh, this is whack.
So it's about how many molecules does the river discharge every minute. Okay, so we're going to have to do something here in a moment to go from the correct units. Okay, so right now, if I look at this, it says a certain river discharges this many liters in every second, right? So I'm going to go and write, see here, let's get these markers up. So we've got 2.9 times 10 to the 8 liters, okay, of water every second. So for every 1 second, that is what is happening. Does that make sense? Okay. Now, it says that every what does it say? Liter of water? So it says a liter of water. So what we've got here, it says 3.35 times 10 to the 25th molecules for every 1 liter. Does that make sense? Okay. So if I were to multiply these things, what units cancel out?
The bottom two. 1 second.
So for things that cancel, I got to have the same thing on top and the same thing on the bottom, right? It's got to be something divided by itself. So doesn't this liter and that liter, don't they cancel out?
Yeah.
So what you'd be left with would be molecules per second, right? What's the question one? Molecules per minute. So I need to figure out how many minutes there are per second, or seconds per minute. So what I want to do here is that we want the seconds to disappear and minutes to show up. How many seconds are in a minute? 60. So now if I multiply this stuff up, liters disappear, seconds disappear. All I'm left with is molecules over minutes, right? So those are the 3 numbers that we need to multiply together. Now, when we do this, what numbers are going to be the best to multiply together here?
2.5. 2.9.
Okay. So let's see here. So we're going to take the 2.9, and we're going to multiply it by 3.35, and then we're going to multiply that by 60, right? Excuse me, 582.9. 582.9. Now it'd be times 10 to the, because I haven't multiplied these things together yet, right?
34 is in it because then you go over 20.
Well, that's, when I go 8 and 25, what's 8 plus 25?
32, right?
33.
33. Sorry.
Okay. So now,
And then 35.
okay, so now you're saying I'm going to move that over 2 spots to make it 5.829. And times 10, so I moved it 2 spots to the left, so that's got to go 2 numbers up.
35.
Excuse me, 35.
I got the answer right.
Now, obviously, this is not what I want us to kind of focus on and use. But if I did this, just to check.
How do I do that? I have the same numbers. What?
Okay, so if I multiply all that stuff out, what does Desmos do for me? It's showing me the correct answer here. All right, so but what I want you guys to understand is, even though we have technology that can get us to the answer, I want us to understand what is the technology doing. How are we getting to that answer? Okay, there's 2 approaches to kind of teaching high school math classes. Do I teach you how to be successful on that test at the end of the year, and only successful on that test? Or do I teach you in a manner that is going to allow you to be successful on that test, but also be successful on the next course, and the course after that, and the course after that? And that's kind of the way that I think I should teach you. So this stuff here, even though you can use your calculator here, if this is a question on the test, you can type in your calculator, multiply, gives you the answer the way you need it, check that answer, okay? But doing this process is going to help you in a science class. It's going to help you in an Algebra 2 class, in a stats class or something like that later on. Yes?
That answer that you have is wrong because, you know why?
Why?
It says round to the nearest 100, and that's not round.
Okay, so if it says round to the nearest.
But then that's not the actual answer.
Yeah, I just tried it and I didn't round. Guess what it counts out?
No.
So these.
I literally got the answer right. Exact.
No, I have a thing. No.
Oh my god.
Well, let me.
And so how does that phrase that question?
Read it. It says use scientific notation, use a multiplication symbol amount. You know, like round to the nearest
100.
Yeah, as needed. And I look.
Okay, so there this is what I'm assuming that they're talking about here. Just kind of follow along because I don't always 100% agree with Math Excel because think about this. If they say round to the nearest 100, okay, they're probably saying 5.83, right?
Yeah.
That's not the 100th place though.
Wait. Oh, it's.
Because this is times 10 to the 35th, so this needs to be moved 35 spots, right? So that's not the 100th place. That's why I don't even know what number that would be. That would be up in the
So million.
like beyond that, okay? Because 12 is trillion. So 15 would be quadrillion. 18 is quintillion. Okay, so that's I think that's a bad misphrasing of how to round. Okay. Yeah. Okay. So I want just per time right now, guys. I want to stop with the homework. I've decided to leave that open for one more day, so that'll be open until tomorrow night. Okay. Now, depending on whether this snow that Ollie's asking about freezing is going to actually freeze or not, and we're maybe not here tomorrow, that's still going to be due regardless tomorrow at midnight. Yes, Hunter. Is it?
No, it's changed.
We're supposed to get windy.
It's gonna snow over.
Oh, I hope we don't get canceled.
All right, so let's talk about this concept here. And this is just you hear me say this a lot. This is an extension of what we've been doing because it's still multiplication. What is 4 times? Think about this real quick. Order of operations: parentheses, exponents, multiply, divide, add, subtract. Right? What do I have to do first? Parentheses. So there's stuff inside these parentheses, right? What does that mean? What's 4 to the third really mean?
4 times 4 times 4.
Okay, so inside my parentheses, I've really got that, right? Now, I've still got this 2 right there, correct? Okay. Now, if you want to change that to 64, you could, but I don't want to right now. What does 4 times 4 times 4 squared really mean?
4 times 4.
Okay, so this would mean, this picture here would mean 4 times 4 times 4 times itself 2 times, right? It would mean that. What do these back-to-back parentheses right here mean? Multiplication. So would you agree that we got 4 times 4 times 4 times 4 times 4 times 4?
Yeah.
How do I write that with exponents?
4 to the
64 squared.
6.
4 to the 6th. Does that make sense? Okay. So working my way from inside out, 4 cubed means 4 times 4 times 4. But 4 cubed means 4 times 4 times 4 times 4 times 4 times 4. And if I think about how many times I said 4 times itself, that's a lot, it's 6 times. So how can I make the jump without having to do this stuff in yellow? I can go from that initial statement to my answer by just taking those exponents and multiplying, right? That's what it said. This is a quicker way. So if I've got 4 raised to the third squared, I'm going to rewrite that as 4 to the 3 times 2, which is 4 to the 6. Okay? So we call that a power to a power or an exponent to an exponent. Okay? But the pattern should work no matter what we use. So if I go, let's go a to the second power raised to the 5th. Okay? Does that mean, what does a squared mean?
A times
A times a, right? But to the 5th means you have how many of those?
5 of them.
5 of them. So then if I go back through, and count how many of those a's that we're actually multiplying together. You guys said it's a to the 10th. Okay, that's it. I won't say that's it, but that's one of the key properties to that. Okay, and here it is written in generic terms. If I have some base a, it's being raised to the nth power, but then that whole thing is being raised to the nth power n. Then all we have to do is take a and raise it to the m times n. Okay. So all you gotta do is, we call that a power to a power, or raise a power to a power, or an exponent to an exponent. Okay, those are going to be phrases that you hear. Okay. Yep. Now, one thing I want to make sure we understand here is that these sections, I would argue, changing a negative exponent to a positive exponent. Was that hard by itself? Not really, right? You got to flip the spots, right? Changing them from numerator to denominator where they started. If I ask you to multiply 2 squared times 2 to the third, you know you're going to, like basic, you add the exponents, right? That stuff wasn't entirely difficult all by itself, right? This stuff, not all that entirely difficult by itself, right? But when we merge all these things together inside one problem, then they start to get fuzzy. We start to forget some of our rules and our properties. So make sure you learn them very well individually, and then when they merge together, it's going to mitigate a lot of that confusion, okay, of what to do and when to do it. And we'll see some of that here in the near future. So let's go through. Stuttered. Let's go through some examples here. What'd you say? That's what I thought she said. My little 5-year-old yesterday, like she kept talking about her butt itching, and like she misspoke, and she kept saying her butt was itching with a capital D. It was hilarious. And then she heard herself say it, and she's like, "No, mommy, no, mommy, no, mommy." I mean, we always tell her if she like slips cuss words, we're gonna call the cops on her. And, like we have in our family we have he used to be a sheriff. He's a detective now. I'm always like, I'll call Corey, and she flips out.
5.
She's 5.
He just said.
Okay, so let's do this. So you guys don't have to do this, but what this means is that I've got n to the 4th times 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 n to the 4th.
We get it.
Times n to the 4th. Now, if it was written this way, think about what we did yesterday. What would you have done, or 2 days ago? What would you have done? Because they're all like bases, right? You would have added those 7 4s, right? But adding 7 4s is the same thing as 7 times 4, and that's where we get that right there. 7 times 4 is 28, so n to the 28. Okay? So the next one's going to be p to the 20th. How about this one? P to the 20th. Okay? Sometimes, and at the conclusion of, I don't want to say conclusion of the course, but once we get really close to the end of course exam, I'm going to take a couple weeks, and we're going to see practice problems, and we're going to attack them 2 ways. We're going to attack them through the algebra that I taught you, and then we're going to cheat and try to use technology to get the answer as well. Okay? Because I want to give you a fighting chance if you get to something that you don't know how to do, that you can at least use the Desmos calculator to help out. So what they do, it's circumventing the algebra, I guess. What they'll ask you to do is they'll make questions that say, okay, is p to the 5th, the one I saw a couple days ago was it gave you something like that, and then it asked you to come up with, and it basically gave you 6 other things to choose, and said, mark the 6, or mark the ones of these 6 that are the same as that. Okay, so if I want to go, p to the 4th, raise that to the 5th, or if I want to go p to the 20th, okay. So it's equaling 1, it's saying 1 here because I've chosen what p is. Okay? And basically what I want to do is see if all 3 of these things are the same, and I don't like where I put p, let's put p down here. If I put p equals 1, it evaluates them all to be the same number, right? What if I make it 2? Is that all the same number? What if we make it -2? Are those all the same number? Okay. So what's that tell me about these different expressions? They're all the same, aren't they?
Yeah.
Because when I choose a value to substitute, they produce the same result. So on that test, if I didn't know the algebra that we just kind of went through, you can at least kind of maybe manipulate the equator or the calculator to help you maybe come across a logical conclusion. Okay. So at the conclusion of like March, mid-April, maybe we'll start doing that kind of stuff. This one here, this one's a little bit different. Okay. Parentheses, exponents, multiply, divide, add, subtract. That's the route, right? That's the order of operations. When I look at parentheses, I look at y to the third. Is there anything I can do inside there that y to the third? No. Is there anything I can do in the y to the fifth? No. So those parentheses really don't do anything for me. Exponent, though, there's an exponent here. That power to a power overrides the other exponents. Does that make sense? We have to address that first. Okay? You might want to write down on this question or questions like it that the first thing you have to do is power raised to power. That's the number one thing in all the problems that we go through. That has to be attacked first because of what we know with that exponent there in the order of operations. So how do I rewrite y to the fifth raised to the negative 2?
Y negative.
Y to the negative 10. So now I'll have y cubed times y to the negative 10th, right? What am I going to do with that? Okay, now here's where it gets, yeah, that's what I'm saying. That's what I said at the beginning. By themselves, these properties are not that bad. But here, we have this power to power property, the new stuff today. But now we get to this stage, okay, we get to that stage, and now we have to use what we learned 2 days ago, right? So now I multiply like bases. You're going to add the exponents. So y to the negative 7th. And now we have to use what we learned 3, 4, 5 days ago, right? How am I going to rewrite that? I don't like negative exponents, right? So I'm going to take it to the bottom. And I get 1 over y to the 7th. That make sense? You guys do the next one. Do x squared times x to the 6th to the negative 4th. See what you come up with. Went x squared. Left that alone because you can't touch that yet because you got a power to a power, right? You got to do that first. So that gives you x to the negative 24th. So then, same basis, so we're going to add these exponents. So it gives me x to the negative 22nd. Okay? Now just remember, do I want to leave it that way?
No.
So what should I rewrite that as? Take it to the bottom. Well, once it goes to the bottom, it becomes positive. Is that something we can do?
Yeah.
All right, let's go a little bit further with this. I know we got about 7 minutes here, so just stay with me. If I go, this is the thing in parentheses, okay, does not have to be a singular thing. So last one was like x to the 4th, okay, or x to the negative 6, or x squared. It doesn't have to be singular. It can be a product of things, okay. Think about what 4m cubed would mean, because they got parentheses around that. That means everything's getting cubed. Does that make sense? So 4m cubed really means 4m times 4m times 4m, right? How many 4s do you have there? Can I rewrite that as 4 times 4 times 4? And your m's like this, right? But this 4 times 4 times 4 you said is 4 cubed, is it not? Does that make sense? Now you could change that to 64. I don't want to right now. And the m times m times m would be m cubed, right? What, just to recognize a rule here, what is the exponent with this 4? 1, right? What's the exponent with this m? 1. 3 times that 1, 3 times that 1 gets me straight to that 3 and straight to that 3, okay? If I did this, let's just go 3 squared, x to the 3rd squared. Wouldn't that mean that I have 3 squared x to the 3rd times 3 squared x to the 3rd? Does that make sense? Could I rewrite that as 3 squared times 3 squared times x to the third times x to the third. And wouldn't this be 3 to the, 3 to the fourth, because I'm going to add those exponents, right? And this would be x to the 6, right? Well, how can I get that answer straight away from that stuff right there? Multiply those two things, right? Multiply those two things. And that's all these next two statements are saying right there and right there in your notes. Is that that a, b raised to the nth is just saying when you have a product raised to an exponent, that exponent is going to get applied to each one of those factors of your product. So we rewrite that as a to the n, b to the n. If your product for some reason doesn't have exponents of 1, okay, then you're going to take that exponent, multiply it by that one, and then that exponent multiplied by that one, and that's what you get over here. So it's kind of like a distributed property with exponents. Does that make sense? Okay. So let's go down to, what's the exponent with this 3 right now? 1. What's the exponent with the x? 1. So how am I going to rewrite that? 3 to the fourth. X to the fourth. Okay. Now you eventually look at 3 to the fourth is something we could do. 3 to the fourth is 81. If you want to simplify those, you can. I think Math Excel is probably going to want you to type in 81. What about this one? What's the exponent with this 2? 1. So what is the, just tell me what I'm going to write. 2 to the 4th, a to the 12th, b to the 8th. 2 to the 4th is, anybody know? 2 times 2 is 4, times 2 again is 8, times 2 again is 16. All right. What about, well, this next one? What's the exponent for 4? M? Okay, so now tell me what to write. Okay. So is that going to be 16 m squared n to the negative 6? Do I like negative exponents? So it's going to be 16 m squared over n to the 6. Okay. Briefly, we got 3 minutes. Do that last one. Jay, didn't you fill all these notes in?
Jaden.
We've been watching. So it'd be 9 to the 8th, right? Now I'm not going to expand that. That's like 43 million. Okay, so I'm not going to do that. A to the negative 16th, b to the negative 8, c to the 4th. Okay. So now I don't like negative exponents, right? So we'll leave the 9 to the 8th where it's at. Where does a to the negative 16th go? And it becomes positive, right? Where does b to the negative 8th go? Bottom. And then where does c to the 4th go? Okay. So if you are typing this in on your calculator to see if you've done this correctly, you're going to type that in just like you see it. You're going to type the two things in the boxes just like you see them. And then after that, you're going to say A equals some number, B equals some other number, C equals some other number. And when it calculates it, you should be able to see that it substitutes and evaluates those to be the same thing. Does that make sense? So you can choose anything that you want for A, B, and C in that situation. The only thing there is that it's probably going to put your answer in scientific notation because that 9 to the 8th is like I said, it's like 43 million or something like that. Okay, give me a second.